friends. Welcome to Stream 4 of Space Week. I'm Kiki. Nice to see you all. Well, let's get to our show today. So our guest today has her PhD in astrophysics. She specialized in the Andromeda galaxy. I hope I said that right. Which is 2.5 million light years from Earth, which seems really far, right? But it's actually the nearest major galaxy to our galaxy, the Milky Way. Now she works at the Lawrence Livermore National Laboratory, and one of her roles includes asteroid hazard mitigation, aka pushing asteroids with nuclear energy. What? Let's bring her on. It's Dr. Kirsten Howley. And I think I actually just said your last name wrong.
You said it right, Howley.
I did.
Yeah.
Hi, welcome.
Thank you.
So I just want to start out by saying you and I have the same first name and the same nickname.
Yes, that's right. So
I'm going by my nickname today, Kiki, and we're going to be addressing you by your correct name, Kirsten. It's so nice to have you joining us. You are very accomplished. You have a really important job. So it's going to be really interesting learning about what you do and how you are like a superhero, essentially.
I'm really looking forward to sharing my job with you and the things that I work on. It's pretty fun.
So I said a little bit in our intro, but kind of like tell us what your day-to-day is like working at the Lawrence Livermore National Labs.
That's a really great question. And a lot of people think that I put on a white lab coat and I go into a laboratory and I do all kinds of experiments, but it actually looks really different. I typically sit in front of a computer all day and I simulate physics events on my computer using supercomputers. So we model asteroids, we model how asteroids would respond to a nuclear detonation, we model how that would result in an impact with Earth. So we look at those types of things, but we do all of that on a computer because that is our laboratory.
Okay. Since you are using computers all day, do you have a background? Do you have to know computer language?
Yes. So I do many different programming languages, and I learned that while I was in school. Every institute, every job uses something different. And so the goal is to be flexible. It's not that you have to specialize in one language, it's that you understand how to learn a new language.
Got it. So you have an extensive astrophysics, background education, but you also have a bit of computer science, I take it.
Yes.
Wow.
A little bit of both. More focused on physics. Computer science is the tool that we use to do our physics.
Got it. See, the lab has the third largest supercomputer.
That's right. We at some point we're in the top two. I think we actually had the top supercomputer at some point, but we're always industry is always making faster and faster computers, and so our computers very quickly become outdated as somebody else has an even faster one. So we have a building dedicated to our supercomputers. It's very cool.
Wow. And these aren't quantum computers.
No.
Okay. Quantum computers, that's like a whole nother level.
Yeah.
But I'm sure once quantum computers become a little bit more usable, then they'll probably become incorporated into the work that you guys are doing at the lab.
We are starting to use GPUs, which are graphics-based computers, using graphic cards, and so we are keeping up with the industry standard.
Wow!
But we're not quite at quantum computing yet.
Slurpy Burpee asks, what areas of STEM do you need to study to become an astrophysicist?
So that is a very good question. I studied physics and astronomy. But for my current work, there are people that worked on geoscience. We have people that were aerospace engineers. So for astrophysics specifically, it's astronomy and physics. But to do the kind of work that I do, you can have a background in chemistry and engineering and many of the science disciplines.
HCS Clark is asking, how does an astrophysicist differ from a physicist, if at all?
They are different. So astrophysicists mainly look up, look at the sky, look at celestial bodies, look at the universe and its formation. Physicists tend to look at physical phenomena, usually Earth-based, but it can be, extraterrestrial. However, in some ways they're interchangeable. They focus on different things. So astrophysicists, we tend to focus on light because that's what we can observe coming from outer space. So I did a lot of work looking at how to process spectra, looking at light coming from stars. But you get a lot of the same background for doing physics and for doing astrophysics. So just a little bit more specialized.
Okay. Well, I am really interested in diving into this topic that we've teased for the show today, which is planetary defense. You are using, you particularly are focused on nuclear, I think, but there are different.
That's right.
Another way that you help basically save the planet from incoming, I'm going to call them space rocks. But I know that's not a technical term whatsoever. But I would love to know, us not scientists kind of know of 4 different kinds of flying, like space rocks up in space, like asteroids, meteors, meteorites, and comets.
Yes.
Is that correct?
Yes. Yes. Meteoroid, meteor, similar. So,
Okay.
So let's start with the biggest. Okay.
Okay.
So comets. So comets are very large, and when I say very large, larger than a mile, usually in size. They are made of primarily ice. So they're kind of like the water you drink out of a cup. I mean, they have a couple of other things, but primarily made out of ice. And they have orbits that take them far out into the solar system and then bring them very close to the sun. And they have periods that tend to be very long. So we're talking on the order of tens to hundreds of years. So we don't see them fly by very often, but they are big. And when they come close to the sun, they move very, very quickly. So those are comets. They're less common. There are fewer of those than there are, at least in our neighborhood, there are fewer of those than there are of the next object on my list, which are asteroids. So asteroids are rocky bodies. They tend to be made out of, the rocks you find on the ground outside. And they tend to be kind of more in the inner solar system area where all the rocky planets formed. And there are many of those. There are, tens of thousands of those bodies in the inner solar system. And they also all orbit the sun. And for the most part, we never really have any contact with asteroids or with comets. Okay. The next group are meteoroids, or meteors, as you said. Meteoroids are pieces of asteroids that broke off. So they're little chunks of rock. And if you've ever observed a meteor shower, what you're basically looking at is a little debris field of chunks of either an asteroid or a comet that have come off as it enters the Earth's atmosphere and it burns up. Now, if any of those little chunks make it to the ground, that's a meteorite. So once it touches the ground, it becomes a meteorite. So not when it's in space, but when it's here. So if you, I have a couple of meteorites myself that I like to look at and, look at all the different colors in them. And because you can actually get a piece of outer space here on Earth, right? And that's pretty cool.
Wow. So the asteroids, you said, are rock. They're basically made of chemical. No, they're not made of chemical compounds. It's not made of iron or metals.
It can be made of iron. Usually iron and nickel, silicone, a bunch of different other rock-like materials. There's a variety of them, right? They're not all the same. They're not all identical. And so some of them are almost all iron, and some of them are, almost all silicon dioxide, which is like quartz. So you have a plethora of space rocks to choose from, right? Just like if you were to, go to your local forest and pick up a bunch of rocks, none of them would really be identical. They'd all be a little bit different. So same thing in outer space.
Wow. So, okay. And I guess meteorites that once they're on the ground, they're not too uncommon, right? There actually is stuff falling from the sky more often than we know about. It's just not necessarily very dangerous.
I have seen many, many, many shooting stars. So every time you see a shooting star, that is a meteor entering the Earth's atmosphere, and it's getting burned up. So it happens all the time. It's not as common that it makes it to the ground. You have to be above a certain size typically to make it to the ground. But sometimes larger objects will come in and they'll break up in the atmosphere, and then you'll get like a little raining down of meteorites. And there are people that actually go out to the desert or to places where they know that there has been a recent, meteorite fall, and they will go and find these objects and collect them. And that's how oftentimes you'll find these little rocks, and they can associate them with which asteroid they came from. And it's because they know when they impacted and they went and collected them specifically. They knew the impact was going to occur. So it's not always a surprise when we have, meteor impacts and meteorites on the ground. We can often predict it. Not always.
I know. I saw news recently that they found something in like Botswana that they had tied back to a specific, I mean, you probably know more than this. This is me like reading a news headline. But they were able to trace it back to the meteor or comet that it came from.
Yes.
And now I know why.
Yes. Yes. So especially when we have these meteor showers, right? Because we often know what asteroid or comet left that debris.
Right.
Usually it's a comet, but sometimes.
We have a question. I didn't know planetary defense was a career until I came to LLNL. How did you discover that planetary defense was a career path?
That's a great question. And I wish I had a really direct answer. Oftentimes, it's opportunities become available as you go along in your career. And when I finished my PhD, I had the option of either pursuing planetary defense at Livermore Lab or pursuing the study of the Andromeda Galaxy at NOAO. And I chose to do the planetary defense track. It was something new and different, and I got to work with a great team, and I knew Livermore had great computing resources, and I really wanted to explore that world. And so it was an opportunity that became available to me. It wasn't something I had planned to do on my career. But in all fairness, I had planned to do many different things in my career, and that often change. So, we all think we might do something, but as we learn more and we learn about new areas of study, sometimes something we didn't even know about becomes more exciting than what we were planning on doing.
That's such a common story that we hear with, I would say, most of the women that we have on Mission Unstoppable.
Yeah.
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 So I feel like what you do is a relatively new area of science. So I guess we as like humans didn't have a way to defend the Earth from incoming asteroids or comets, kind of before your field was developed. So I'm going to guess that it's not too often that we have, extinction level events, happening. So how often does this happen? I know the dinosaurs became extinct because of something like this, but it can't be that often. Are we in immediate danger? What's going on out there? tell me why we should feel safe.
Yeah, the dinosaurs were incredibly unlucky, right?
Yeah.
They did not have a way to protect themselves. And things, so the asteroid, the comet that killed the dinosaurs was very large. And when I say very large, I mean more than a mile in size, probably more like 10 miles in size. And those type of events are extremely rare. Um, I think, greater than 100, probably on the order of 100 million years, but incredibly rare. And and so we typically don't worry about objects that size, and especially because back in the 90s, Congress tasked NASA with finding all of the objects a kilometer size and larger. And currently, almost all of them have been found. More than 95% of these kilometer-sized near-Earth asteroids have been found. We know where they are. We track their orbits very carefully, and we would know if they were an imminent threat. And we don't see anything in the next 100+ years that's a kilometer size that we're concerned about.
Okay.
A mile.
What does near Earth mean?
So that's a good question. There's a very specific scientific definition, but just to kind of give it to you in more simplistic terms, it's something that comes close to Earth, so within about 20 moon distances to the Earth, that is larger than, that comes within 20 lunar distances. We categorize it as potentially hazardous if it's also 140 meters or larger in size. So about a football field and a half in size or larger. So then it not only is a near-Earth asteroid, but it's a potentially hazardous asteroid. So we have a lot of definitions, right? So
okay. And then do you find these from ground telescopes or maybe from satellite telescopes or a combination?
So most of these are found with ground-based telescopes.
Okay. Wow. So are you also looking for asteroids or meteors that could hit other planets as well, or are we not concerned with that?
That's their problem. We were very interested in the comet impact into Jupiter, the Shoemaker-Levy 9 comet impact that happened, and this was some decades ago. That was a very interesting event to us, but in general, we don't pay much attention to impacts to other planets.
Got it. Yeah, it's their problem. Okay,
problem,
so
yeah.
Does Earth have any sort of natural defense? I am guessing our atmosphere does something to help us.
Yes, and it's one of the advantages we have over a lot of the other planets, as well as our moon. So, right, if you look at the moon, you can see the moon's surface is riddled with craters, and that is from asteroid impacts. All those craters are from rocks hitting the moon. Right, and the moon doesn't have an atmosphere. So we have an atmosphere that helps protect us. And most of these objects, when they enter our atmosphere, either burn up or break up. And so what that means is that it doesn't reach the ground, or if it reaches the ground, it's not the same size, or it's broken up into many pieces. So our atmosphere is really, really helpful to us. I mean, for many reasons, of course, but one of them being protecting us from asteroids and from meteors.
Oof. Thank you, atmosphere.
Right.
Let's take care of it. From the chat. Do you ever have the chance to share your findings with people in power, such as the White House or Pentagon?
So we do have a direct relationship with NNSA, and we frequently communicate with them. We also communicate on a global stage, so it's not just our own government that we're concerned about. This is an international effort. If something were to impact Earth, it may not just affect us, or it may not affect us at all, right? It might affect another country. And so we all work together to come up with a mitigation strategy if something were to be on a collision course with Earth. So we do communicate all the way up to our government, our federal government, but we also communicate with other countries.
So I know there's, if something were to be coming towards Earth that you scientists have decided, okay, this needs to be taken care of. I know there's two different ways to approach the situation. There's nuclear and kinetic impactor.
Yes.
Okay.
Yes. So there's
so let's talk
numerous
about
methods
those.
that have been, there's actually a bunch of methods that have been proposed, right? And
Oh,
so
okay.
kinetic impact nuclear are the most energetic of those methods. And so we at Lawrence Livermore focus on those two methods because they are the ones that could tackle really big objects. And we collaborate with NASA on how we would get a kinetic impactor or a nuclear device up to an asteroid. And so this is, again, we're not just working on our own. We work with others that are also experts in this field. So the way that these two things work is the goal is not to push the asteroid into a new orbit. So we don't actually change the orbit. A lot of people think, we hit the asteroid and it goes flying off. It doesn't work that way.
Okay.
What actually happens
I think we have a fun video. Are we going to do, which one are we going to talk about
great.
first?
Me?
Yeah.
Okay. So this is the nuclear option.
Okay.
You detonate the nuclear device, it deposits energy into the asteroid, and the asteroid gets a little push such that it misses the Earth. The idea is that you're not actually changing the orbit of the asteroid. What you're doing is you're changing its speed. So it either arrives a little bit early or a little bit later. So something that was going to originally hit now gets there a little earlier or a little later so that it doesn't actually impact Earth.
Okay. So you're not blowing up these asteroids or comets.
Right.
You're just giving them a little nudge.
That's right. Basically, we're vaporizing the surface to make it a little rocket that pushes itself a little faster or a little slower.
Because if you were to, for lack of better terms, blow it up, then you would have millions of little asteroids showering down.
Yes.
I believe.
That's right.
And we don't want that.
Some scenarios we might want that, but in general, we'd like to have a more controlled approach. We can't really predict how it's going to break up, right? We can predict how we're going to push it. So we want to go with the more solid solution literally more solid solution.
Right. So in the case that you decide that using the nuclear approach is the way to go, should we on Earth be concerned at all with the radiation that happens from the energy?
No. The wonderful thing about space, one, it's big. Two, there's already a lot of radiation in space because of our sun. We have our atmosphere to protect us. These detonations aren't occurring, in our right above the Earth. These are far away. And there is essentially zero fallout risk on Earth, right? You are at more risk from the sun and the UVA and the UVB rays, and you should wear your sunscreen and protect your skin. Like that is more of a threat to you than detonating one of these to deflect an asteroid.
Okay. All right. The sun is a huge threat to me personally. Yeah, I wear SPF like 100. Okay. And then the other way that you focus on at the National Labs is the kinetic impactor. So let's throw up that video.
Yes.
Okay.
So here we have an asteroid. We deploy the same spacecraft, but now it doesn't have a nuclear device on it. And we intentionally crash that spacecraft into the asteroid. And it does the same thing that detonating a nuclear device would do. It gives it a little push so that the velocity changes. And when we say velocity changes, we're talking a centimeter a second, right? This is really a really small change in the velocity of the body. But it's enough that it arrives a little earlier or a little later, especially when you have many orbits for that to accumulate over. So yeah, we just crash it right in there. We just intentionally drive our very expensive rocket right into the surface of the asteroid.
Okay. And since you've been working in planetary defense, how often have you had to deploy either of these tactics?
This many times.
Okay.
So
that makes sense.
So this is one of those situations where you have a very low probability, but very high consequence scenario, right?
Mm-hmm.
So basically, we anticipate that we will hopefully never have to use any of these methods, but we want to be prepared just in case that we would have to use it.
Okay. Well, that makes me, and I think everyone watching, feel very good. First of all, the chances of this happening are so, so, so slim. And then we have people like you that are taking that extremely slim chance and saying, nope, bye.
Yeah,
So, essentially, we have nothing to worry about.
right.
Great.
Right.
Okay.
Yes. We are on the job, and there's nothing
Yeah.
that we have identified that's on a collision course with Earth in the next 100 years.
Okay. I want to take a couple questions here in the chat. HCS Clark asked, what are the differences between meteor showers and shooting stars?
Oh, none.
They're the same thing.
They're basically the same things. Yes, they're basically the same thing. They are a shooting star is a meteor that's entered the Earth's atmosphere and burning up and makes a beautiful little streak across the sky.
I don't know. I think you are in the Bay Area, so I don't know how well you have light pollution there, and down in Los Angeles we have light pollution here. So seeing
Yeah.
meteor showers isn't something that I have the luxury of doing ever. But I'm sure if you live in like a nice rural part of the country, you can probably see those, fairly often.
Yes, I mean, I have seen them when we have, there are events where there's, we're coming into the tail of comet debris, and there's a beautiful 5 meteors per hour, and you can see them. But we probably, being in these light polluted areas, have a better chance of seeing more of a fireball, which is a larger chunk entering the Earth's atmosphere. And I've seen a couple of fireballs, which are also very cool.
Oh my gosh. Robocop says light pollution in the East Bay actually isn't too bad. So that's lucky.
Not as bad as LA.
No.
Not as bad as LA.
Actually, I kind of like it though. It feels like a nice warm blanket.
Nice little light haze every night, right?
Yeah.
You don't need street lights.
Yeah. Another question. In addition to asteroids, does your group study science debris that might be hazardous to Earth, such as the core of Long March 5B rocket that's supposed to fall back to Earth?
So the lab does work on space debris. Our group does not, but there is a group of people that specialize in that.
Okay.
Good question.
We
wouldn't use a nuke for that.
What are the typical compounds of a meteor?
So it varies, right? But typically we kind of approximate them as being quartz-like. So there's many different materials that we think are asteroid-like, forsterite, silicon dioxide. We look at things that have, water, some things that are more water-based, but it really varies asteroid to asteroid. But there are some fundamental compounds, and those kind of encapsulate them, as well as nickel iron. That would be another one we would consider to be asteroid-like.
Has there ever been any debris that's fallen to Earth as in the meteorite that has been studied and found that what's located in it is not of Earth? It's something that we don't recognize.
Well, none of them are of Earth, but there are some that have come from Mars or from the moon. Some of them are not from asteroids, right? Some of them are actually from our other, neighboring planets and moons.
Okay, but it's never, you look at what's building this, meteorite, and you don't recognize the compounds within it.
Elements. No, that hasn't happened. We haven't discovered any new elements from an asteroid or meteor impact.
Got it. Okay, so I want to talk about Bennu. How far away? And this is an asteroid, right?
Yes.
So how
Yes. So
far away is Bennu?
Bennu is about 200 million miles away. It's fairly far away. It has an Earth-like orbit, so it's comparable to Earth's orbit around the sun. It's a little bit different. It's a large object. It's 500 meters in size, which is about half a mile. Um, and it's a very interesting body. There's a probability, a 1 in 2,700 chance that Bennu could hit Earth in 2175. So more than 100 years from now.
Hmm.
We will have more information before then. And it's not going to be, in our lifetime, but we would like to help our subsequent generations be prepared in case that was a threat. Bennu is not a catastrophic size asteroid. It would be a bad day. It probably could take out a state. It's big enough to do that, but it wouldn't take out a country.
Okay.
Well, maybe it would take out a small
Um,
country.
everyone watching now, unless we find, the a miracle, immortality, we probably won't live to see the very small chance that Bennu could impact the planet.
Yes, and
Okay.
it's less than 1% chance, right? It's less than
Right.
0.01% chance.
Hmm.
So, or probably about 0.01, but it's a very small chance, and we will know better when we are able to get more information about its orbit in the future, about what trajectory it's
Hmm.
on. So there are these events called keyhole events, where there is a gravitational shift from a close encounter, and that can determine the final trajectory of the asteroid and give us a better clue about whether or not there will be an impact. So Bennu
Okay.
has such an event in the future, but we'll have to wait till then. I think it's like 2135 or something. It's far in the future where we're not too concerned about it right now.
Right. And you said it's currently 200 million miles away. And just to
Yes,
help me wrap
Fr-
my head
uh,
around that, do you
from
know
from the
like
sun.
from the sun? Okay, it's 200
Yes,
million
it's
miles from
very
the
hard to.
sun.
Yes, and its distance from Earth varies. Sometimes it's very close, and sometimes it's much further. It
Okay.
has an orbital period of, I think one, it's a little bit over a year. So it has a slightly different orbital period, and it has close passes to Earth every 6 years. So I think it's
Okay.
1.2 years is the orbital period. So there are times where it's very close, and there's times where it's very far. So it depends when
Okay.
you're asking.
Okay. Do you know how many million miles away Earth is from the sun?
Comparable. It's comparable to Bennu's
Okay.
distance.
Okay. All right. Well, we'll
Astronomers
keep an eye on that.
astronomers actually use the distance from the Earth to measure distances for other objects. So we kind of define the distance from the sun to the Earth
Okay.
as an astronomical unit.
And anyone watching now that wants to hear more about Bennu, we're going to be covering that a bit in depth on our stream tomorrow with Beth Johnson from the SETI Institute. And she's going to be talking about um, something that was landed on Bennu, and they're drilling and taking samples.
Yes,
And she's going to get into that tomorrow with us.
Osiris Rex. Yes, very
Yes.
cool.
Yes.
That is worth
Um,
tuning into.
I'm excited. Um, okay, we have more questions. Do astronauts, spacecrafts, rovers, etc., ever get impacted by asteroids and meteors?
I so I believe that there are impacts, but from dust-sized particles. So very small, small particles. And the, there are no, certainly there could be a larger impact, but larger pieces of debris are less common, and space is really big, and there's mostly empty space out there. So it would be like you being at the beach and throwing, a tennis ball and trying to hit another tennis ball, on the other side of the beach, right?
Right.
And that would be very difficult.
Okay. And let's cover the inaccurate portrayal of that in Armageddon once we once we get to that, because I think that's an opening scene of the movie where an astronaut gets hit by like a meteor on the space station.
Oh, okay.
Okay. Next question. Is it true that astronauts are hit with small particles of radiation when in the ship? How has this affected astronauts in the past?
So astronauts are not afforded the same luxury of protection from the sun's radiation like we are here on Earth because we have the atmosphere. Mm-hmm. And so certainly exposure to radiation, cosmic rays, radiation coming from the sun is a concern. I don't specialize in that, but it is something that is taken into account. One of the great things is you can often shield against many of these energy types. And so I'm sure NASA takes precautions to do that. But I unfortunately, I'm not an expert in that, but they do have to think about that.
Okay. I'm so sorry. I meant to read Panda. Great question. Then we'll get to the next question that was on the screen, which I totally missed. And now we'll get to it. If and when people start going to Mars, ooh, this is a great question. Will we start defending 2 planets?
Mars doesn't really have an atmosphere either. It has a very, very thin, sad atmosphere. That's an excellent question because Mars is going to suffer the same impact risk that we suffer. There won't be as much population, so the chances of an asteroid hitting, a base station is much less probable. But I don't know. That's a good question. I think it's not as easy to do. I think the risk is small enough, and the sending the capabilities to defend against that are expensive enough that might preclude us from doing it. But I don't know. Maybe way off in the distant future, when SpaceX is just zipping people to and from, maybe we will.
Right. This leads me to a question that we ask all of our guests this week. If you had the opportunity, would you go to space?
I have a very well thought out answer, and the answer is no.
Okay. Because it's dark and scary. That's Aaron McDonald's answer.
Because I'm afraid of heights, so
okay,
that doesn't help. I think space is incredibly cool, and I think that there are a lot of people that are explorers and are ready to go and see what's out there and have that experience. And I do think it's absolutely amazing. I'm afraid of heights, so I'd rather just kind of I like Earth's gravity, and I like Earth a lot.
Totally.
So I'll stay here.
I'm with you.
Yeah.
I'll take videos, take pictures. I'm so happy to look at that.
That's right.
I'm not really interested. Would you go in a, let's say a submarine or a unit like that to a very deep level of the ocean?
I probably would not do that either. The pressure's down. I would probably go to space before I went deep into the ocean.
Okay.
I think the deep ocean is a much scarier place than outer space.
Yeah. It seems maybe it would be
Personally.
A little bit claustrophobic.
Yeah, there's a lot of water above you. There's a lot of pressure deep in the ocean.
Yeah.
Submarines are amazing. So let me just also put that out there.
Yeah. Okay. Star Trek and other sci-fi TV series movies inspired RoboCop to learn about space. And Kirsten, what inspired you to study space?
I also loved Star Trek. Growing up, it was one of my favorite shows to watch. I also really enjoyed special relativity and general relativity and Albert Einstein, and the discoveries that he and his wife made. I think those are amazing. All those things really inspired me. Black holes, I thought those were just so cool, and I still think that they are so cool. the Big Bang. So all of those things really inspired me to pursue astrophysics. I wanted to know more, and I wanted to understand how it worked. And sadly, I learned more, and I still don't understand how a lot of it works. But right, at least now I can understand why I don't understand, and I can think more deeply. I think time travel is really cool, and I see that as being physics and astrophysics related. There's just so many cool things.
Yesterday when we were speaking to Dr. Erin McDonald, who is an astrophysicist and she's a consultant for Star Trek, she was doing an amazing job at teaching us, you know, light speed and warp drive and how light travels straight, but if you have mass, then space bends, and
Yes.
it just is so like mind-boggling, and I could not wrap my head around it. I feel like
It's very cool, and it's not out of the realm of possibilities. We could do warp drive using nuclear detonations. Those would work to help us reach close to the speed of light. Like it's very possible. We can do it. It might be very expensive, but we certainly understand how it can be done.
yeah, yeah. I mean, it would take, you know, it would make a 6 month travel to Mars, like, what, 6 hours? If that?
It depends how fast you could go and how quickly you could get up to that speed. You know, you're limited
Yeah.
because you can only accelerate by, about a G at a time. That's what the body can handle. So how close can you get to the speed of light? I haven't done that calculation. I mean, I'm sure somebody could sit down and do it, but
Right.
um, and I don't know if she mentioned. I'm getting a little off track, but there's also the twin paradox that you have to be concerned about. So you age differently the closer you get to the speed of light. Time is relative. So somebody that is moving close to the speed of light, you leave, go to Mars, come back. Let's say you have a twin. Your twin might be 40 and you might be 20, right? And so
Right.
there's time dilation that occurs. So you gotta take that into account also.
Yeah. Do you do any work with the NIF, especially stimulating nuclear reactions to materials?
I do not directly work on NIF. I have a lot of colleagues who do experiments on NIF. It is a very cool experimental facility. We mostly study material properties of asteroid-like bodies, and we really want to understand how those materials would respond to nuclear type energy. I think there have been some experiments proposed on NIF, but I don't think that we've done any yet for asteroids
We
specifically.
had another Mission Unstoppable guest that works on the NIF, at the NIF, Dr. Tammy Ma. We were talking about plasma physics and creating
Yes.
stars and using that energy
Yes.
to power the grid and just crazy cool stuff. Guess you're doing a lot there at the lab.
Yes. We have a lot of scientists.
So cool. I hope that someday we can take a trip up and visit
That
and
would be
see all the cool
wonderful.
stuff. Yeah.
Give you a tour of the facilities. That would be great.
Oh my gosh, it'd be so cool. Okay, a couple more questions, and then we will get into Armageddon and Deep Impact, which
Okay.
I am so excited to talk about. Slurpy Burpy asks, "What happens to us if humans travel faster than a G at a time?"
That's a great question. I don't know biologically what happens. I just know I know it's very difficult for humans to handle, and at some point there's some acceleration that would probably be fatal. But I don't know. I don't know the specific answers to those questions. I just know it would not be a good day. You would not feel
Yeah.
well.
Yeah. Well, you know what? That leads me into, I guess, the Hollywood of it all.
Yes.
So there are two very famous movies that deal with blowing up asteroids and comets. They are Armageddon and Deep Impact. Both, I think they're both made in the 90s. probably came out very like similar like years to each other. And I want to talk to you about the maybe a few things that they got right, but all the things that they got wrong.
Yes.
So Armageddon. I watched this last night. Laughable. Highly entertaining, but
Very entertaining.
just oh my gosh. You're obviously not supposed to be laughing at it, but was laughing through the whole thing. So in Armageddon, there is a asteroid the size of Texas that they suddenly realized they had 18 days to, to blow it up, or else there would be a world extinction. So let's get into, first of all, the movie starts out with an astronaut on the space station who I believe is on a spacewalk that gets killed from like a meteor, or a meteor. So we know that wouldn't happen, or most likely would not happen.
Very unlikely.
Yeah, and very unlikely
for that to happen.
That they would have absolutely no heads up.
The heads up is likely. Oh, so you mean about the asteroid or about the meteor?
Right, just like, whoa, where'd that come from? Like, they would know that it was coming, right?
So there are many problems with that asteroid. I think it was nicknamed Dolly. So they said the asteroid was, I think, 700 miles in size, which I think the theoretical upper limit for a comet is like about 40 miles. So a 700-mile asteroid, near Earth asteroid, let me be specific, is not realistic.
Mm-hmm.
We would have seen something that big.
Mm-hmm.
So to only discover it 18 days before it's going to hit Earth, you should have higher confidence in us than that. Maybe the dinosaurs would not have been able to see that coming, but we certainly, with all of our telescopes, would have seen something that big on the collision course with Earth. So that wasn't realistic.
Right.
That wasn't realistic. Maybe the asteroid getting hit by something in space, but not an asteroid that size.
Right. And then the president of the United States took his top scientist, the smartest guy in the country, and he said, we have to put I think it was like a nuclear bomb inside of the asteroid, and that was the only way that they were going to be able to make sure that it didn't impact Earth. So why would we not want to put a nuclear bomb inside of an asteroid?
So let me say, there might be some scenarios where we would want to.
Okay.
But in this particular case, if I remember correctly, they had a very specific depth that they needed to drill down to, yes, and drop the nuclear device. The surface of the asteroid looked nothing like the surface of an asteroid. It was like all kinds of jets coming up, and it wouldn't look like that. And
it looked like there's like steam vents.
Yeah, it would look like steam vents. You might get that on a comet, right? As it passed close to the sun. That's why you get those tails on the comet. But you wouldn't expect that from an asteroid, because asteroids don't have a lot of volatiles like water that would be outgassing, like they showed in Armageddon. And honestly, at that point, when you have something that big, I mean, you really should just, do your Hail Marys and call it quits, because you're not going to deflect a 700-mile diameter asteroid in 18 days. It's just not going to happen. You would need, in order to split it in half and push it in two opposite directions, you would need energy that's equivalent to the total energy output of the sun in a day. And we don't have that capability. We can't produce that kind of energy. That's a lot of energy. It's a big object, and you're just not going to do it in that time frame.
No. Is there anything else from this movie that stuck out to you as being completely scientifically inaccurate?
Oh man. God, there were so many things that were inaccurate, but I think we touched on the most egregious things: the
Yeah.
size, the deflection technique,
Yeah.
the way the asteroid appeared. It was just, it was a very entertaining movie.
Yeah.
It was a love story, right? I mean,
Yeah.
but it wasn't realistic.
Okay. So then let's switch over to Deep Impact. So in this movie, which is probably a better movie than Armageddon, the team, so there is a comet that's approaching Earth that was discovered by a couple of kids using a telescope. They sent their findings to the head of their, like astronomy club, who happens to work at a telescope in Arizona or New Mexico. And then this scientist, when he had these findings, tragically died in a car crash.
Yes.
1 year later, the world has found out about this and realized that they have about 6 months to take care of this comet, or else there will be world destruction. And their method of, deflecting the comet was to send up a team of astronauts, land on the comet, and I think blow it up. I think.
Yes.
And then they end up actually, instead of blowing up the comet, they crack it. So now there's a mini two comets. They made they took a problem and they made it worse, almost.
Yes.
The small comet ends up crashing into Paris and destroys Paris. And then the larger comet, everyone has kind of just decided that this is it. We've made a bunker situation where 1 million people can live, and we're going to repopulate the planet. We've brought 2 flamingos and 2 elephants and 1 million people, and we are going to repopulate the Earth. But then the astronauts that are in space realize that all they need to do is just crash their ship into that big chunk of the comet, and they save Earth. Okay, Kirsten, what did they get wrong, and what did they get right?
Okay, so the impactor, it's actually a comet, is more realistic, right? The comet is more realistic. It was about 11 miles in diameter. And the thing about comets is they mostly live in the outer solar system, in the Oort cloud. And, they're still in orbit around the sun. They move very slowly when they're in the outer solar system. And as they come in, they move very quickly. And so it's very possible to have a short warning time with a comet. There are much fewer comets than there are asteroids, and so we tend to worry about them less, but they are much more disastrous objects to be on a collision course with Earth. Mm-hmm. So that part is realistic, right, in terms of the object and the warning time, right, which I guess is about 1 year and 6 months or so, right? Mm-hmm. So that is more realistic. In terms of deflecting the comet with a kinetic impactor, so first I know they used a nuclear device, right? And broke it into 2 pieces. Also realistic. And that is one of the biggest uncertainties is what are these objects made of? Are they 2 lobes that are stuck together? If you have 2 lobes that are stuck together, you could detonate it, break off 1 lobe, and have another lobe, right? That was very realistic. That's something that we actually worry about when we're thinking about deflection or disruption scenarios. They were going for a disruption scenario where you break it up. Mm-hmm. So having that smaller piece hit first, and then having this larger piece kind of in the wake, realistic. However, that larger piece was still pretty big, right? And the reality is you would not be able to deflect that with a kinetic impactor, especially not on that time frame. So kinetic impactors are really good for objects that, we either have a long warning time or they're smaller in size. And by smaller, I mean, a few 100 meters in size. So something like 3 football fields or less. But this was a comet that was originally 11 miles in diameter, so it was still going to be a really big object, even after that little chunk broke off. And It probably would have taken multiple nuclear devices to break it up into more pieces. But if you're going to do something like that, you need to be really smart. And if you're going to have all that debris rain down on you, you don't want it raining down all at once. You want it to disperse a little bit. Because if you break up an asteroid and a bunch of little pieces, all enter the atmosphere at the same time, what's going to happen is they're going to burn up and they're going to heat up the atmosphere. And then now you have a very hot atmosphere that can set fires and cause all kinds of problems. So better, closer with the science, but still a little Hollywood there at the end.
Okay. So then I guess that probably answers this question in the chat of which is more accurate, Armageddon or Deep Impact.
Yeah.
We're going to go with
Deep Impact.
Deep Impact. Okay.
Ding, 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 ding. Yeah, for the win.
Okay. Well, this was so much fun. I learned so much. You are great. You're a great science communicator.
Oh, thank you.
Yeah.
Thank you. I had so much fun. I love talking about this stuff.
Yeah, this was really cool. I feel very safe. And everyone watching should feel very safe. And
yes, absolutely.
I know that the Lawrence Livermore Laboratory has a really cool Instagram. I follow them. CBS Unstoppable follows them. So I would say, do you happen to know off the top of your head what the handle is?
I don't. I'd have to look it up. But
okay, that's
I'm
fine.
sure if you just look up LLNL, you can find it.
We'll put it into the chat.
And also, I wanted to add,
yeah,
your space shirt is very cool.
Oh, thank you. Thank you so much.
Yes.
Yeah, it's got some moons and some stars representing. So everyone should go follow Lawrence Livermore National Labs on Instagram. Really cool content you guys are putting out. Really entertaining. A great follow. Even if you're not in science, you'll learn a lot. It's very cool. Let's see. Anything? Do you have anything to plug?
I would just say, STEM is wonderful. No matter what you decide to pursue, it's an exciting, rewarding career, and you're always learning and you're always being challenged. And I highly recommend it. I've had so much fun, going through school and in my career now. It's not a job, it's something that I love to do and I enjoy doing every day. So I encourage it.
Awesome. Thank you so much for taking an hour out of your day to join us. Really appreciate it. And we'll let you go because we've had you for an hour and you have really important things to do. So thank you so much again and have a great rest of your space week.
Thank you. You too.
All right. Bye.
Wait, you don't follow CBS Unstoppable on YouTube? How will you know when new videos drop? You better go subscribe before you miss a crazy STEM moment, like me walking a shark or making a black hole in my backyard.